Hi Bharat.
Hi.
So, what is your demo today on AI lifecycle solutions?
Yeah, sure, sir. Can you see my screens?
Yeah, I can see that.
Yeah. All right. Yeah, this is the AI development life
The
cycle.
slide, you tell what it is actually about the demo, then
Yeah, sure, sure.
you
So
skip to that.
today, I would be, presenting the data layer, the second, the second, part of AI development life cycle. Previously, we talked about problem definition. Now, my presentation is completely on a data layer. The data layer is a foundation that actually converts banking activity into trusted data for fraud AI engine. To start with, the first slide uh, about the data layer, I'll just explain the core activity from where the data is collected by the bank, the data source for banking. I would I would say by core banking, card transaction, UPI payments, internet, mobile banking, ATM system, you know, merchant gateway authentication and fraud investigation. So bank generates enormous amount of data every time a customer performs an activity. For example, um, um, a customer does a transaction of 50,000 rupees on a day. The bank will verify with the you know with the uh, with the transaction from which device the customer has made. Is that the trusted device? Uh, that's how uh, the data layer would decide whether it is a genuine transactions or not. Or a customer logs into the mobile banking, checks their balance, transfer the money through UPI, withdraw cash from ATM, or makes a card payment. So that is how the AI would decide whether it is a genuine transaction or not. So each activity generates different types of data. The data layer brings all these uh, source together so that the AI system gets a complete view of transaction and customer behavior. So the key point I would say the data layer acts as a bridge between the raw banking system and and the fraud AI engine. It collects the data, cleans it, enrich it, and prepares for a fraud detection in future. So I'll go on to the next slide to explain uh, where actually the data layer fits in AI lifecycle. So uh, the life cycle shown here is business problem, data, module, evolution, deployment, monitoring, and feedback. Uh, the AI lifecycle starts with the business problems. You know, in this case, raising financial losses due to undetected fraudulent transactions. So this is where the data layer comes in. The data layer prepares trusted data for layer three model development. Um, the data layer activities like the data source injection, data quality, and labeling, feature engineering, and secure data. For example, um, if you think about an AI lifecycle like building a house, business problem, why are we building? You know, data layer would be the foundation model, building the structure, and when it comes to evolution, quality of the construction, deployment, making it available for for the user or the customer, you know monitoring it, checking the quality of the building, and feedback, improving it. So if the foundation is poor, the entire system will become unreliable. So you know even if we use a very adverse AI model, the model cannot perform well in underlying a data in incomplete and incorrect you incorrect information. So let's talk about what does you know in our next slide, uh, probably, what does the data layer actually do. So the data layer turns into raw banking activity into AI ready data. The slide shows the flow, starting from raw banking activity: collect, ingest, validate, transform, and serve. So the raw banking activity, this is the original information generated by banking activity. For example, customer transaction, payment, login activity. It could be internet login activity or mobile banking activity, ATM withdrawal, card activities, and device information. For example, a transaction may initially look like a card number, amount withdrawn, time when the amount was withdrawn, merchant where the payment has made, and what was the device. So this is the raw information which will be collected on the back of our transaction. Collect. The data is collected from multiple banking systems, as uh, we talked about in our earlier slide, where the core banking, card activity, UPI, ATM, mobile banking, logins, and payment gateways. So the customer profile. So once the customer, uh, you know, uh, might be connected with the customer profile, previous transaction, devices, and location, merchant, and uh, authentication history. So that's where the data is collected. Ingest, the collected data is moved to data platform. The real times, we there will be a real times streaming and batch or ELT. So the real time is used um, when we need an immediate fraud decision. So batch processing is useful for historical analysis and model training. Validate. The system checks whether the data is trustworthy. It would check the missing values, duplications, incorrect format, invalid values, inconsistency, and business rules. For example, if the transaction amount is 10,000, but the another system records it has 1 lakh, uh, more than uh, uh, what the transaction amount, the data quality layer should will detect the inconsistency. It will transform the raw information is converted into useful information. For example, the transaction time is 11:42 p.m. It can be a late night transaction, true or false. Serve. Uh, the final trusted data is made available for fraud AI model. The data layer does not simply stores the data, but it converts the raw banking events into trusted, standardized, and AI ready information. We'll talk about the banking data sources in slide number 6. So the main, I would say, the objective of banking data source, multiple banking sources are unified to create a trusted data foundation. So this slide explains the several important sources like core banking. It contains account information, customer profiles, KYC, loan information, and account activity. For example, an AI can understand whether the transaction is normal for the customer account. Yeah, a customer whose normal balance is 50,000 suddenly attempts a 10 lakh transfer. So maybe this becomes an signal for fraud. So that's where the system would identify such transaction and alert the customer. Card transaction, which includes debit card, credit card, card activities, any chargeback. So, for example, a card is normally used in Hyderabad. Within 10 minutes, the same card is used in some other country or some other location, which which indicates a suspicious activity. That's where the customers will be notified about the card transaction. UPI payments, which include um, the UPI, IMPS, NEFT, RTGS, payment request. So, for example, normally a customer makes a UPI payment of 500 to 2000. Just for an example, suddenly, um, yeah, suddenly a 2 lakh payment is initiated to a beneficiary. So the data layer capture these information and alert uh, the customer. Internet and mobile banking, which includes the login of the application or mobile banking, funds transfer, bill payment, beneficiary management. So, um, to give an example, a login happens from a new device, followed immediately with a large fund transfer. The combination is more useful than looking at the transaction alone. So, when it comes to ATM systems, which includes withdrawal, balance inquiry, ATM events, card and PIN activities. So for this, whenever a customer normally withdraws a rupee, it could be, just for an example, 500. Suddenly, multiple withdrawals are attempted within the short period. The system can identify its unusual withdrawal behavior. Merchant or gateway includes it includes the merchant's details, payment logs, settlement data, or chargeback information. So the fraud detection becomes stronger when we combine data from multiple sources instead of analyzing uh, only only one transactions. So it would involve the multiple information from multiple sources, combine the data, and analyze whether it is a fraud transaction or a genuine transaction. We'll talk about the end-to-end um, or the you know turning raw banking activity into AI ready data. So the main objective of this slide is the banking events, the injection, validation, data uh, platform, future pipeline, fraud AI model, and risk sources. So the data payment sources, it is the core banking activities, card, UPI, mobile banking, you know, merchant gateways, and authentication system. Um when it comes to the okay, give me a second. Yeah, sorry. Yeah, sorry. Um, yeah, when it comes to banking and payment sources, the data comes from the banking activities, card, UPI, mobile banking, and ATM, the merchant gateways, and authentication system. Injection, the data enters through two major parts. One is real time streaming, and which is batch and ELT. Okay. Just for an example, a customer makes a UPI payment and the card can immediately enter into a streaming pipeline. So historical transactions can be processed later through uh, batch processing. Data validation. The system performs a data quality check, duplication checks, format validation, business rule validation, and any data inconsistency checks. The uh, the data platform. The slide shows the raw data, clean data, and curated data. When we think of these three levels, the raw data is original information, um, and the clean data, which is validated and standardized by the AI, curated data, enriched and prepared especially for the analytics and AI. Future uh, pipeline features are created from a curated data where it is you know it is enriched and prepared for analytics. So for example, transaction frequency, so based on the past transactions, it comes up with the frequency, uh, how when the customer is doing the transaction, average transaction amount, device changing, location changing, merchant risk, authentication strength. It will also calculate, for example, if we are doing a transaction at a home laptop, and after some time, if we are doing a transaction from our office laptop, so that's how we collect those data and you know keep those data. And whenever the customer does the transaction from these devices, it would say it is a genuine transaction. When we talk about the fraud AI model, the model analyzes these features, products, a fraud risk ratio is generated. For example, the risk ratio, which is comes out from the transaction which is made. If a risk ratio is about 92 by 100, It is a high risk. So the the architecture shows how a simple banking event is gradually converted into meaningful fraud risk decision. Okay, we'll move on to the next slide. The Okay, one second. Okay, there's some issue. There's some issue with my slides. Give me a second. Mm, okay. All right.
You have PDF, right? PDF file. You can use that.
No, I did not. Yeah. Okay, I got it. Now I got it. Yeah. Yes. Okay. I'm sharing my screen now. Okay. Hope you can see my screen. Yeah.
Yes, now
Slide number 8. I would say slide number 8. Why fraud detection needs data paths. The real time streaming is equal to immediate protection. Batch or ELT equals to continuous learning. So both such kind of analysis are required. So to talk about real time streaming, used when the bank needs immediate decision. For example, transactions, amount, time, merchant, device, and location. Um, when a customer makes, say, about 1 lakh transfer, the bank cannot wait you know, until the next day to analyze it. The transaction will be evaluated within milliseconds. It will decide whether the transaction made is genuine or not uh, based on the transaction uh, amount, location, genuine, valid device or not, merchant. It will possibly, uh, you know, it will take a possible decision whether to allow or block the transaction, or whether to give any authentication to the customer. It could be OTP or any other authentication to the customer to validate that particular transaction. So path 2, batch or ELT, used for historical data. It combines the historical transactions, confirmed fraud outcomes, customer information, device information, merchant information, and location information. This helps create a richer feature and training data sets. For example, suppose the bank um, has 5 years of uh, history of the transaction of the customer. So the bank processes and calculate uh, the customer average spending on monthly basis. You know, typical transaction times, location, common locations where the customer does the transaction, frequent merchant, normal transaction frequency. So these patterns help the model learn what is normal transaction and what is abnormal transaction. So the key statement I would say for this slide is streaming protects the customer now, while the batch processing helps the AI become smarter over time. I'll move on to the next slide. The data quality foundation of trusted fraud AI. The main message I would say, garbage in is garbage out. If a poor quality data enters the AI system, the fraud module can can produce a poor decision. So my this slide shows the data quality engine. So the important check I would say, one is missing value. For example, a transaction has an amount of 50,000. The merchant is missing and the location is missing. So the system needs to determine how to handle this. Second, duplicates. The same transaction may accidentally happens twice. So, for example, a transaction ID of 1001 appears two times. And if this isn't correct, the AI may think the customer made two transactions. Talk about invalid amounts. For example, a transaction of rupee 5,000 for a normal payment transaction. Maybe this may be invalid. So when we talk about invalid location, for example, the country is if the country is unknown, the data quality system should flag it. The data quality system will flag it. The timestamp issue. If the transaction's timestamp is incorrect, fraud data based on transaction velocity or the time can become inaccurate. So why the data quality matters? The the poor quality data can lead into false alerts, missed fraud, false alerts. Maybe the user will get false alerts on the transaction. Um, Missed fraud, when there is a real fraud happened to the customer account, that's where the AI would miss uh, to capture that fraud. Wrong decision, poor module accuracy, and customer inconvenience. For example, if a legitimate customer transaction is duplicated 10 times, the AI may incorrectly think that the customer is performing unusual frequent transaction. So the key statement would be, before asking AI to detect fraud, we must need to make sure that the data itself know, can be correct or trusted. So yeah, I'll move on to the next slide. How does AI knows what fraud look like? The trusted labels, better training data, and smarter fraud AI. The AI needs examples of what is fraud, what is legitimate. These are called labels. So, for example, a transaction was supposed to have amount of 50,000 on time, on so and so time, and with so and so merchant, and the trusted device, location. Initially, the transaction may be unknown. Uh, the fraud investigation team would investigate, and the investigation found that maybe it confirms the fraud. Uh, it would come up with a fraud label called one. If the investigation confirms it is a legitimate, you know, the system would come up and provide a label called legitimate zero is equal, equals to zero. So why the labels are important? The the model learns from the historical examples. If a transaction made um, to a frequent merchant, uh, the AI would come up and give an outcome that yes, it is a legitimate. If it is unusual transfer, suddenly you are making a transaction of 10 lakhs, you know when your regular transaction is 500, you know about 5,000, and suddenly you make a transaction of 10 lakhs. So that's where the AI system will come up and uh, you know give it could be a fraud transaction. When you are transferring the amount from a new device and it is a large transfer, the AI would come up and give as a fraud transaction, and then simultaneously the customer would ask for the additional authentication to validate that transaction. So the AI identify patterns in uh, you know these examples. You know, when I would say weak labels, the slide highlights the problems with weak labels, like poor model accuracy, incomplete investigation, wrong outcomes, inconsistency, inconsistent decisions, missed frauds, and false alerts. So, for example, if a transaction is marked as a fraud simply because a customer complained, but the investigation later shows it was legitimate, the model learns the wrong pattern. So, the key statement for this slide say the quality of the label is just the importance as quality of the transaction data, because of model learns from the outcome from the customer outcomes. We'll move on to the next slide, turning transactions into fraud signals. Uh, uh, AI does not simply look at the transaction, it looks at the behavior behind the transaction. Stage one, raw transaction. For example, uh, customer making a similar payment during the similar time, same merchant, and same location. At this stage, it is simply a transaction data for AI. And future engineering, the system converts the raw information into meaningful signals. Spending deviation. Um, you know, for example, if, is this a normal, unusual amount unusual compared with the customer normal spending? For example, normal average is 2,500. The customer transaction is 85,000 or 90,000. This is a significant deviation. That's where transaction velocity. So, how quickly the transaction is happening. 10 transactions within 2 week, 2 minutes. This could be suspicious. That's how the AI would decide whether it is a fraud transaction or legitimate. New device. Is this transactions coming from device the customer has never used before? Unusual location. Is this location different from the customer normal location? Merchant risk. Uh, the customer is making uh, uh, transferring the amount to different merchant, authentication history, uh, whether the strong authentication was successfully completed or not. So that's where these information will be stored. AI behavior signals. AI can also consider a spending pattern. It will also consider the spending pattern, times pattern, location pattern, device pattern, and transaction frequency. Uh, s- Stage 3 fraud AI. The engineered feature are sent into the AI model. The model, proceeds a risk score. So the data uh, which is which is transferred into the AI model, it comes with the risk score. For example, if it is in a high risk score, if the risk score is equals to 92, it is a high risk. Possible action. It will block the transaction, or gives a step of authentication, or it would investigate. Um, the key statement for this slide is, feature engineering transforms into simple transaction fields into behavior signals that AI can use to identify suspicious pattern. We'll talk about protecting banking data throughout the life cycle. The security and the governance are the core cutting controls across every stage of data layer. My slide explains about the encryption, access control, masking, um, audit logs, data retention, compliance. When we talk about encryption, uh, the data is protected um, at rest, in transit. When the customer makes a transaction, or the customer transaction information moves between system, it should protect from unauthorized access. So that's where the encryption comes in. Access control. Only authorized people should access sensitive information. For example, a fraud analyst may need transaction information, but may not need access to every customer attribute. Masking. The sensitive information should be protected. For example, instead of displaying the complete card number, uh, the system will show only last four digits of the card number. That is what is masking or tokenizing. Audit logs. The system records who accessed the data, when they accessed it, what they changed. So this is how the audit logs are updated in the system with time and all other information, useful information. Data retention. Keep only the data that is required according to the policy and business needs. So rest all information which would be purged out from the system. Compliance. Banking system must follow the applicable banking and privacy requirements. So the I would say the security is not something we need at the end, but the security must exist throughout the completed data life cycle. We'll talk about data security and governance. Um, so this slide uh, talks about the security, governance, and business benefits together. Security controls. Encryption protects sensitive banking information. Access control ensures only authorized users can access these data. When we talk about identity and authentication, it verifies the user and the system or the device. Data masking protects sensitive information, and threat detection helps identify suspicious access or activity. Backup and recovery helps protect data against loss and system failure. When we talk about governance framework, data quality defines how accurate the reliable and reliable data should be. So, it would decide whether did the from where the data came from and how it was transformed. Metadata management maintains information about data sets and fields. Policy management defines rules, standards of using data. Audit and compliance, it would provide evidence that requires controls are being followed. Business benefits. So this slide highlights the benefits such as high trust, safety. The customer and the bank can have a greater confidence in the system. You know, based on the higher trust and safety. Regulatory confidence. The bank uh, will demonstrate the appropriate controls and compliance in order to safeguard the data. Reduce fraud losses. Better data uh, can be improved. For the fraud decisions and reduce the losses. Strong customer trust. Customers are most likely to trust the banking system, that provides their data and transactions. You know, whenever the data and transactions are the information is protected, the customers are most likely to trust the banking system. Sustainable business growth. Yeah. Sustainable business growth. Yeah. Reliable AI and strong governance provides a foundation of scaling the solution. I would say the key statement for this slide is the governance ensures that our data is not only useful for AI but also secure, traceable, compliant, and trustworthy. So I will move on to the next slide, which is data layer at a glance. So this is the summary slide. It connects everything together, like banking system ecosystem, curated data, trusted future, broad AI, business impact, banking data ecosystem. So the data comes from core banking, card transaction, um, ATM, UPI payments, internet, mobile banking, merchant and payment gateways. So this is the banking data ecosystem. Raw data, original data collected from different banking system. Um, the clean data, the data that has been validated, the data has been validated, standardized, duplicated, checked for consistency. From AI, curated data. So once the data is cleaned, validated, data that has been enriched, organized, and prepared for the analytics and AI for further analysis. Trusted features, for example, customer behavior, transaction velocity, spending deviation, device information, location behavior, and strength. AI, fraud AI, the AI use trust features to detect suspicious transaction. It would calculate the risk and complete fraud detection and protects the customer. Uh, so when we talk about business impact, the slide connects the data layer to several business outcomes. You know, higher fraud detection, better data given to the AI, better information for detecting suspicious behavior uh, for any future transaction. So when the when a better or a genuine data is given to the AI, so that's where the information is detected, and it will be helpful for the customer for detecting suspicious behavior on their accounts or card. Faster decision. The real time data enables the immediate for fraud detection. Lower loss. So early detection can help reduce the financial losses. Regulatory confidence, strong governance and security support support compliance will give a uh, confidence, regularity. Customer trust. Customer gain confidence when the transactions are protected, when the data is protected. That's where the um, uh, customer trust the banking system. So that's where I would close the presentation. Just to summarize, the data layer is a foundation of the AI based, banking fraud detection solution. We need to collect, uh, we collect data from multiple banking sources, ingest it through real time and batch pipelines, validate and clean it, and applies the label and feature engineering. So, and protect it through security, governance controls. Finally, we provide a trusted feature to the fraud AI model so that it can detect suspicious transactions faster, more accurately. In simple terms, the trusted data leads to trusted AI, and the trusted AI helps create uh, safer banking. So
Bharat,
that's all I have.
please go to that life cycle slide. Show me
Sure,
that
sir.
life cycle
Sure, sure, sir.
picture. 7 layers.
Yeah,
No, 7 layers cycle is there, right? Second slide.
yeah. Second slide,
Yeah,
sir. Can you see?
yeah.
Yeah.
So you have done problem definition demo with solution with the same domain,
Yes.
bank fraud. Then now you have done the data layer presentation, solution presentation. Then you are going to work on the model development
Model
solution
development.
also. So next one is of, layer three. You are
Yes.
going to work on that, right? Yes.
Correct. Correct.
Fine, fine, fine. So we'll stop recording.